All right. Hello, this is Shawn Chumbar. This is my YouTube video for the Transformers and Fine-Tuning with LLMs assignment. I will be presenting both Part A and Part B in one video. So yeah, uh, let's start off with Part A. In this notebook, we go ahead and implement NanoGPT. You'll see that I've included the references that I've used. I have used ChatGPT for help. So to start off, we're going to go ahead and git clone the nano GPT git repository, cd into that repo. We're going to install some packages as well as install some other libraries as well, like Torch, Torch Vision, Torch Audio, etc. From there, we then check the Torch version. So you'll see here we're on 2.0.0 CU18. I'm using the A100 high RAM runtime type. We then go ahead and download Shakespeare's works and create the data directory. So you'll see here, this is where I'm doing that. We go ahead and prepare the data, and this includes defining the input and output paths, reading the input text, getting all the unique characters, creating a mapping from characters to integers, encoding the entire text data, converting data to integers, splitting data into training and validation sets, and saving the data to .bin files, which I will attach to the directory. You'll see here we save the mapping for decoding, so vocab size I2S and then S2I, and then we go ahead and open it and dump it into a pickle file. Then we're going to go ahead and run the data preparation script, and you'll see here this is still this is more like configuration for NanoGPT. We describe the out directory, the evaluation interval, evaluators, and log interval. We keep going. We check if the CUDA is available. You'll see here it was. We were using the A100. And then we begin training. And this takes a long time. And you'll see here, it took about 4,025 milliseconds just for the last step. Loss is 0.82, MFU is 13.33%. And that's it for part A. So for part B, in this portion of the assignment, we implement the textbooks are all you need case study. We start off by installing required packages, importing the packages, and then setting the device as CUDA. And since we're using A100, you'll see here we are indeed using the device CUDA. We then define a whole bunch of helper functions in order to pre-process the data set, create basic concepts, create the data structures, create algorithms, create advanced topics, and create the synthetic textbook data. It's important to note that I'm not using as much data because I did use LLMs to generate the data, and they weren't really generating a lot of data. Anyways, so we've got that data set. We then create a function to filter code quality, as well as to set up the model and tokenize the data set. And then also we have the train model function here. And within here, you'll see that for the training arguments, we're using the phi1 mini output directory. We're setting the number of train epochs to 5, batch size to 2, gradient accumulation steps to 4, learning rate, here's warm-up ratio, etc., etc. And we have a custom callback for better progress tracking. Okay. And so we also have a helper function to evaluate the model. And you'll see here, this is where we get into the meat of this, where we're going to be using all the helper functions defined above. So we first initialize the WANDB weights and biases project. We create the data set and pre-process the data set using those helper functions we created. We then set up the model, we train the model, and then we save the model. And then as an example, here's the test generation which is def calculate average of numbers. So you see here, def calculate average numbers for a equals 0 in numbers to length, else a times 10.0 divided by 10 is equivalent to the average of all numbers with an odd number between them. Any two are equal or not at least one digit within blah, 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 blah. So that's what it generated after we trained it on code. And that is the end of part B. Implementing the textbooks are all you need study. That concludes my video for assignment 6. Thank you very much for watching and have a good one. Thank you.